Okay, so this was the second question. So the question asked if you color the grid in with like 3 colors and every color is touching the other 2 colors by an edge, right? And you can color and which grid sizes is that possible to do? So we got first like we do 2x3 and patch it up in 2x3s, but then we realized, hey, the green just extends all the way down, you know? Okay, and then if the green extends all the way down, we get this, okay? Okay, and the thing that you notice here, okay, sort of what Alvin was saying, is if you look at all the squares, like the green needs the red and the blue to be satisfying the condition, right? But the blue doesn't need this red, you see? Yeah? The blue already has a red under it, yeah? That makes sense? So in some sense, so Alvin said delete this one and swap these two, but that's really just the same as deleting this one, right? Yeah? So you delete one of these columns and you move the green one in, yeah? And it still works. That makes sense? Okay. So can you see what that gives you?
A pattern with 5. You can 5 by something pattern.
Yeah, so you can get 3, right? And then you get 6, but now you can also get 5, yeah?
You can just keep doing that. You should just...
Yeah, so you get 5 and 6. You might not be able to get 4, okay? But you can also just keep adding like 2 columns, like green and multicolored, right?
5 and 7 and 9.
So then you get any odd number after 5 and any even number after 6, right? That makes sense? So you can get every number essentially except for 2 and 4. Does that make sense? Okay, so my question to you is, if you can't get 2 and 4, what cases are left? So we got every number except for 2 and 4 by everything, right? What cases are left? I don't know, we got 3. So we got 3 by anything, yeah? We got any number by anything except for 2 and 4, yeah? So the question is, what cases are left?
1, 2, and 4.
We don't have 1, yeah?
1 doesn't work. 2 and 4.
Yeah, but what does it mean to have 2 and 4? So can you see that you actually have, so it's not 2 by anything, okay? Because you can make this into the rows as well, yeah?
2 by 2, 4 by 4, 2 by 4, and 4 by 2.
Yeah, and you don't, yeah, so it's really only just 2 by 2, 4 by 4, and 2 by 4, right? So they're the only cases left. Okay. So the question is, can you do it? Can you do it for 4 by 4 and 2 by 2? And 4 by 2, yeah? So I guess we're not going to spend too much time on it. You might want to do the 2 by 4 as an exercise, which is pretty good exercise, yeah? And the 2 by 2. But 4 by 4 here, you see, you can pretty much draw something that works, yeah? So, yeah, that's it. So why would I say this is a primary school problem? Even though it appeared in the second question of the National Maths Olympiad. Is because it's really you're kind of only really thinking in one direction. Does that make sense? So you're trying really hard to make the coloring work and it just keeps working, right? There was no point where you had to really prove it didn't work, okay? I think in one of the smaller cases you'll prove it doesn't work, but I think that's a good exercise for you, right? Like you didn't have to prove it very generally, it's only for a very specific case. So there's only very few combinations that you had to try. Does that make sense? And the skill comes from reducing the combinations even further. Yeah. Alright, any questions about that? No, it's a nice little problem. Okay.